This video is about understanding and solving problems related to perpendicularity. So first we want to define what is parallel and what is perpendicular. So parallel uses two bars that are straight, and they are lines that have the same slope and never intersect. For example, we have two parallel lines, they're both going the same slant and they will never intersect with each other. Perpendicular then is represented by a symbol that looks like an upside down T, and this is lines that intersect at a right angle. We know we have perpendicular lines because they have opposite reciprocal slopes. So here's a couple examples. We have that A is perpendicular to B. Here we know that this is a right angle because it's got our little box. So ray ED is perpendicular to ray EF. And then our last one, we have a 90-degree angle. So we know that segment GH is perpendicular to segment JM. When we are dealing with parallel and perpendicularity and angles, we can always assume that we have a straight angle that's formed by a straight line, but we cannot assume right angles. So to know if we have a right angle, there's a couple of different ways to know if we have a right angle. So one way is to be told it is a right angle, it's 90 degrees, or it's perpendicular. In the picture, we could have a little box. We can have it congruent to a right angle. We can have a straight angle that is bisected, because if a straight angle is 180 degrees and it's bisected, that's going to mean that it is cut into two 90-degree angles. We know on the coordinate plane, where the x-axis is perpendicular to the y-axis, and we know if lines have slopes that are opposite reciprocals. So in number one, A and B, we are given a statement and we have to use that statement to make a conclusion and have a reason for it. So in letter A, we have that AB is perpendicular to BC, which means it's forming a right angle there. So we could say angle ABC is right. And our reason here is that perpendicular lines form right angles. In letter B, we have ray EF is perpendicular to line DG. So because they're perpendicular at that intersection point, we are going to have two right angles in this case, because we have a line on each side of EF. So we would say that angle GFE and angle DFE are right angles. And we know that again because perpendicular lines form right angles. In number 2, given that AB is perpendicular to BC and DC is perpendicular to BC, we want to prove that angle B is congruent to angle C. So when we do a proof, we're going to do this in a 2-column proof. And what happens in a 2-column proof is one side is going to have our statements and one side is going to have our reasons. Now, this is a shorter proof, but as we get into proving triangles are congruent later this semester, they will get a little bit longer. So when you start a proof, you always start with the given statements. So we are going to say that segment AB is perpendicular to BC and CD is perpendicular to BC. And our reason we know that, it was given to us. Now, because these lines are perpendicular, so if AB is perpendicular to BC, that creates a right angle. And if DC is perpendicular to BC, that creates a right angle. So in step 2, we're going to identify our right angles. So angle ABC and angle DCB are right angles. And we know that because perpendicular lines form right angles. Then, because we know that those angles are right angles, and if we look at just one of the letters, right, we have angle B and angle C, which are the two angles we wanted. So in step 3, we can say angle B is congruent to angle C. And the reason we know that is because when angles are congruent, they have the same measure, and right angles always have the same measure. So all right angles are congruent. In number 3, we want to find the measure of angle 1. So in our first problem, we know that AB is perpendicular to BC, so that creates a right angle. Angle 2 is 52 degrees, 19 minutes, and 4 seconds. So to find angle 1, we know that together the angles are 90 degrees. So we would have 90 minus 52 degrees, 19 minutes, and 4 seconds. So we'll have to borrow a degree to get 60 minutes and then borrow a minute to get 60 seconds. So we can now subtract. So 60 minus 4 gets us 56 minutes. 59 minus 19 gets us 40 minutes. And 89 minus 52 gets us 37 degrees. In part B, line DE is parallel to is perpendicular to line EF. So they are making a right angle. Then we know that angle 1 is 2 times the measure of angle 2. Well, we don't know angle 2, so we can call that x. So if we are 2 times that, angle 1 is going to be 2x. Together, we know that they equal they equal 90 degrees. So we have x plus 2x equals 90 degrees. 3x equals 90, so x is 30. So if I want to get angle 1, 2 times 30 gets us 60 degrees. Number 4, we're given that angle ABO is 5x plus y plus 3. OBC is 5y minus 1. AOB is 12x minus 14. And BOC is 8y plus 2. So we also know that AB is perpendicular to BC, and the two angles at the bottom are forming a straight line. So when we try to write our equations, the first two, 5x plus y plus 3 plus 5y minus 1 is equal to 90. If we organize this to get the x and y's on one side and the number on the other, we get 5x plus 6y is equal to 88. Our bottom two angles are forming a straight line, so together they are 180. We have 12x minus 14 plus 8y plus 2 equals 180. So if we move our numbers and get the x and y, so we have 12x plus 8y is equal to 192. Now we can use those in a system. So we have 5x plus 6y equals 88, and we have 12x plus 8y equals 192. In order to solve, we can multiply the top equation by 4 and the bottom equation by -3. So we can eliminate our y's. So we get 20x plus 24y equals 352. And then we get -36x minus 24y is equal to -576. So when we add straight down, we get -16x is equal to -224. So when we divide, x is 14. Now that we know x is 14, we can substitute back in. So 5 times 14 plus 6y is equal to 88. 70 plus 6y equals 88. 6y equals 18. So y is 3. So our ordered pair would be 14, 3. We want to find the measure of ABO. So ABO, the measure of angle ABO is going to be 5 times 14 plus 3 plus 3, which is going to get us 76 degrees. In number 5, solve for x and y. AR is an angle bisector. So this bisects the angle into two congruent parts. And we also know that the lines are perpendicular. So we have a right angle that is bisected. So each bisected angle is going to be 45 degrees. So we know that WAR is 3x plus 3y. So we have 3x plus 3y equals 45. And then we know WAN is 8x plus 2y. So 8x plus 2y is equal to 90. So in order to solve, the first equation we're going to multiply by 2. The second equation we're going to multiply by -3. So we get 6x plus 6y is equal to 90. And -24x minus 6y is equal to -270. So we add straight down, -18x is equal to -180. So x is 10. Once we know x is 10, we can substitute to get y. So we have 3 times 10 plus 3y equals 45. 30 plus 3y equals 45. So 3y equals 15, which means y is 5. So we have the ordered pair of 10, 5. In our last question, PQRS is a rectangle. Find the coordinates of P. So in a rectangle, we have right angles at each corner, which makes these sides perpendicular. So if P lines up with Q, it's going to have the same x coordinate. So that's going to be -4. And if P lines up with S, it's going to have the same y coordinate. So P is at -4, 3. Then to find our length, or the area of the rectangle, we want to find the length of the sides. So how do we get from S to R? So how do we get from 3 to -5? We went down 8 units, so that length is 8. And from Q to R, we go from -4 to 12, which is a change of 16, so that length is 16. So our area is length times width, so 16 times 8, which equals 128 units squared.